So today I'm going to be talking about doing Poisson regression in SAS, and this is just some Poisson data that I generated, where we're looking at age, sex, and vehicle type, the influence of those things on the number of crashes that an individual has over a specified number of years of follow-up. So there's a 20-year-old who's, how did I define it? Yeah, 0 female, 1 for male. Um, yeah, so you have a 20-year-old female who is in a truck who had 3 crashes over 10 years, right? Nah, it was an SUV. But yeah, so that's what data for Poisson regression generally looks like. And just like a little bit of information about the Poisson distribution, we can see what our distribution of our outcome looks like with prog SG plot. Um, we just do a histogram and have crashes as the outcome. Hopefully that, yep. So this is kind of what Poisson data typically looks like, where the outcome is we're looking at a count. That's what this variable is on the x-axis that peaks at whatever the mean count is, or typically like around the mean, and usually anything less than that is a pretty truncated blunt distribution. Well, things beyond that can go to very large counts that are very underrepresented, and that's typically what a Poisson distribution looks like. Another property of Poisson distributions is that the variance and the mean should be ideally equal or at least really similar. And I can check that with proc means. Yeah, I don't think I need to put anything else. Yeah, so let me just make sure. So standard deviation 1.6. Yeah, it's really, yeah, mean and standard deviation are really close. So we have data that's suited to be modeled with Poisson regression. So for Poisson regression, we use proc, not proc GLM, but proc GenMod. And we specify the data that we're going to be using. We named it Poisson. I guess the first thing you can do is do well, I like to do format first, and I created formats for sex and vehicle. Next, we have a couple of categorical variables, and GenMod has a class statement. What that lets you do is tell them that sex is categorical, and we can also tell them what we want our reference to be. And we add 0 as female, or F, so we can say that as the reference. And vehicle, we can do something similar. And we have car as the referent there. And we are specifying the way we're parameterizing as reference. Okay, so now we actually specify the model. So the outcome is the count, the number of crashes, and we want everything in the model. So age, sex, vehicle, and then here is where we essentially tell SAS that it's Poisson regression. So we tell SAS that the distribution is Poisson. And for Poisson regression, the link function is log. And there's something you put in that isn't a variable that's called the offset. And that reminds me, right now we have person years just listed as person years, but we want it as log person years when we actually input into the model, because at that point it becomes what we call the offset term. So we can just remake the Poise data set, but add this variable where we have now ln person years. I don't know, like it's never log base 10. You just when you tell SAS log, SAS just kind of knows you mean ln in the context of statistics. I named it PYS, right? Yep. And yeah, so now we have like a log or a ln transformed person years variable that we can use as the offset. Yeah, okay, nice. Okay, so yeah, we offset equals ln person years, and this should run a Poisson regression. What went wrong? Thank you, SAS. SAS was able to recognize that I spelled Poisson wrong. That was kind of, I didn't even know SAS could do that. Um, so yeah, there's a few things we can see right off the bat, just looking at this. A problem with what, like I said earlier, is Poisson regression generally assumes that the mean and the variance are equal. A sign that it isn't is if this these or the chi-squared value over the degrees of freedom is large. That's a sign that there might be some over dispersion, and then you might have to reevaluate what distribution you're going to use. And yeah, here we have our values, and as it is that it can't be interpreted, you need to exponentiate it to interpret it. And something just to note here is the way that this design matrix is set up will let's just keep that in mind for when we do our estimates. Oop, that's the wrong thing. So yeah, what we can do here is if we can do estimate, and that's going to put beta, but we can name it what we want. So I guess X is the first one. And yeah, you can put sex, and then sex only has one level, so you can just put 1 here, and then X to tell it to exponentiate. We can do that again for the different levels of vehicle. So you'll remember that the vehicle design matrix has our second one for some reason was the yeah, let's just see. It was, yeah, car is in the middle, so yeah, okay. So if we want to find SUV, we'd put 1 0, or truck we'd put 0 1. So yeah, wait, which one was 1 0? Okay, SUV is 1 0, so we can put SUV truck. Yeah, it's truck. Okay, and then truck 0 1 exp. And then even though age is continuous, you still, if you're going to do this, you still put 1 and then exponentiate. So I'm also going to put output because in a second I'm going to show you just like some really quick diagnostics. So to create a new data set, you can just call it Poise2. This will give us our predicted values, the chi-squared residuals, and deviance residual. Yeah, just use chi-squared residuals for now. So yeah, if we do this, it should do two things. Now it'll give us the estimates that we can interpret as a relative risk for each of these, and also it'll output a new data set that lets us have these predicted and residual values that can let us do some diagnostics. Nice. So now we have exponentiated values here. Yeah, none of these are, well, age is significant, but yeah, that's borderline. But yeah, basically, just forgetting significance here, we would interpret this as males are 1.2 times at a greater risk of experiencing a crash, and same 1.01 times greater if you're in an SUV, 1.4 times greater if you're in a truck, and as you increase in age, it looks like each year you increase age is like a 5% decrease in risk of crashing. Um, and yeah, again, it's not real data. It's just what I chose to do for this example. Um, Last thing I'm going to show you, just another indication that you have over dispersion. That's your main threat as far as assumptions for Poisson, is whether over dispersion is happening. You would plot the residuals, and if the residuals are massive, then it's a pretty sure sign that there's over dispersion. You might be able to correct that by adding more variables. It might mean that there's some important variable missing, but it also could mean that the distribution is just wrong and you need to pick a different distribution like negative binomial or zero inflated. What am I doing? Scatter x equals yeah, some of them are kind of big, but they're not like massive. And we also saw before that where was it? Just this means function. That's also an indication that there's not a ton of over dispersion because that squared is very similar to the mean, and that's the outcome there, number of crashes. But yeah, keep in mind that regardless of what you add or take away from the model, that's going to stay the same because that's just using the raw data. As far as looking to see if adding things to the model corrected over dispersion, it's better to use, I guess, one of two things. So the first thing you'd look at is to see if when you run this, if this value here, like the chi-squared value, if this is getting lower as a result of adding, and also if your residuals are going down. And there's some other nifty things you can do with Poisson, but as far as just getting started on how to use it in SAS, that's pretty much what you need to know.